Yes, welcome to this session. So today we go to see the nature of the quadratic form without reduction. So let Q is a quadratic form. So Q is denoted by Q. Q is equal to x transpose A into x be a quadratic form in n variables. The variables are denoted by x1, x2, x3 up to etc. xn. And let the matrix of the quadratic form is A equal to this. So A11, A12, A1n, A21, A22 up to etc. A2n and ANN. So n cross n matrix. So n variables are there. So it can be able to form. So nn variables. The matrix A is called matrix of the quadratic form Q. So let we want to find d1, d2 up to etc. dn. dn is nothing but so determinant of a11. So only one single element. Determinant of a11 is a11 and d2 is nothing but determinant of 2 by 2 matrix. So a11, a12, a21 and a22. So d3 is nothing but so determinant of 3 by 3 matrix. So we can up to d4, d5, d3. d4 means a determinant of 4 by 4 matrix. d5 means determinant of 5 by 5 matrix. So already we can dn is nothing but n cross n matrix. Therefore, that is so determinant of A matrix. So the determinant d1, d2, d3 up to etc. dn are the principal minors of A. So that a quadratic form Q is said to be so positive definite. So the nature of the matrix we will say. So if it is a positive definite means all the D should be positive. D1, D2, D3 all the D should be positive. Suppose if it is suppose if it satisfies minus I whole power I di, that is d1, d3, d5 are negatives, d2, d4, d6 are positives. If it is satisfies this condition, then we can say it is a negative definite. So for all the dAs are greater than or equal to 0, so it should be at least one dA should be 0. If any one of the dA is 0 and remainings are positive, then we can say it is a positive semi-definite. Here at least one should be 0. Maybe more than 0 is possible also here. So remaining should be positive. So negative definite, similarly the same condition for the negative definite, at least one dA should be 0. So otherwise we will say indefinite. So example number 1, discuss the nature of the following quadratic forms. Here the 4 quadratic forms are given. So the given quadratic form is 6x square plus 3y square plus 3z square minus 4xy minus 2yz plus 4zx, having the 3 variable x, y, z. So therefore here it is from the 3 by 3 matrix. So we will get 6 minus 2, 2, we will form this. So therefore d1 is nothing but determinant of a11, so that is 6, it is positive. So d2 is also positive and d3 we will get, so it is also positive. Since all are positive, d1, d3, d2, d3 are positives, therefore the nature of the quadratic form is positive definite. Then the second one, the quadratic form is 6x2 square, x1 square plus 3x2 square plus 14x3 cube. So 4x2 x3 plus 18x1 x3 plus 4x1 x3 having the variable x1 x2 x3. The matrix of the quadratic form is this. So A matrix is this. From this we want to find the, so d1 is 6 greater than 0 positive, d2 is also positive and d3 is also positive. Therefore we will get this a positive definite. So the third problem, the quadratic form is xy plus yz plus zx in 3 variables x, y, z. So the matrix of the quadratic form A is this. Therefore the principal minors are d1 is 0, d2 is negative and d3 is positive. Therefore, so since d1 is 0, d3 is negative and d2 is positive, therefore we will comes under, which never falls positive definite or positive semi-definite, negative definite or negative semi-definite. Therefore automatically it will becomes under the case of indefinite. So next, the quadratic form 10x square plus 2y square plus 5z square plus 6yz minus 10zx minus 4xy is in three variables x, y, z. Therefore the matrix is of the form A is equal to this. So the principal minus are d1 is positive, d2 is also positive, and d3 is 0. Since d1 and d2 are positive and 1 d3 is 0, therefore it comes under the case of positive semi-definite. So these are the some problems, just we have to note down it and we can solve it for your reference. Thank you.